I started with this picture, which I took this morning because it was interesting. I didn't know that Tarek and also Hinek were going to mention microservices and the REST frameworks and stuff like that. So this is very meta, if you allow me. If somebody takes a picture, we are going to do another recursion here. But yeah, it's fun because Tarek mentioned the complexity that can come with microservices. And also Hinek talk, for whoever of you attended it, was about complexity and building complex stuff. Now, REST is, or I should say Eve, is a project which was born precisely because I was dealing every day with RESTful services. I was tasked with building a network of services, and it came to my mind that we were always redoing the same stuff over and over and adding every time a new layer of complexity. So the idea was most of the stuff these services are doing is often similar. We are doing a lot of stuff, repeating a lot of stuff.Maybe we can do something about that, create something that can make deploying microservices faster. And what I mean by microservices in the Eve concept is microservices which are serving data, basically. So if you have data somewhere and you need to expose it to your clients, this is the use case for Eve. Now, Eve, and again, Tarek mentioned Flask is based on Flask. So if you use Flask, you probably already know how to use Eve. Technically speaking, Eve is a subclass of Flask, so it is inheriting from Flask. So whatever you can do with Flask, you can do with Eve as well. But it adds some features to Flask which are centered towards data, serving data over our REST server. And also, by default, Eve connects to a Mongo instance. So if you are using Mongo in production or you plan on using Mongo, Eve works for you out of the box. We will see that there are some community extensions which allow you to connect a Eve server to, I don't know, SQL Alchemy, and so you can connect the SQL databases or even Elasticsearch. The community has been doing some crazy stuff when it comes to data layers. And also Redis for some features like rate limiting and stuff like that. So a quick start, just to explain you what I mean by easy deployment or easy going to production, if possible, with data. How many of you use Flask already? Okay, so the few of you that are using Flask probably can recognize this code because it is basically how you start a Flask app. It is exactly the same thing. You just instantiate your app and run it. What you have to do in the settings, you have to define the topology of your API. Here we are setting 2 endpoints, people and books. We are just building a Python dictionary and defining that we have 2 endpoints. And then we launch our server. And when we do this, what we get back is a functioning server. Now, mind you, we haven't connected a DB yet, so it is probably not very useful. But just to explain you the concept behind Eve, you can already go and hit the home page. For example, Eve will reply, send a response to you with some data. Let me see if I can turn this on. Doesn't work. Oh, well, yes, it does. So, as you can see, we get an empty array of items because we don't have any data yet, but we are already providing some useful data. Now, this is something that I can't pronounce in English, but it stands for hypertext as the engine of application state, which is a concept in REST where basically a client can use this data, this metadata here to build its own UE and navigate your API just by reading the data provided by the API. So here it is like, hey, look, you are hitting this endpoint and my parent is this other endpoint. So the client can build the navigational UE by reading the data coming from the API. If the API changes, the client can change as well, programmatically. Now, this is a feature that you might like or not like. I found that in real life, very few people use it, but it is very interesting. So you should probably look at it if you don't know about it. Then you probably want to connect to Mongo, and all you have to do is set a Mongo URI in this case. And let's see how this works. Hopefully you can see. This is Postman. I don't know if you know about Postman. It's just a simple REST client. I'm now hitting the people endpoint that you see here. And as you can see, since I'm connected to a database, I'm already getting some data here. So the items array is not empty anymore, just because I connected my Mongo instance and I told that I'm connected to that specific database. So no coding, just a setting file, a dictionary where I configured which collection are mapped to my endpoints, and it just works. Okay, now I connected a database, a data source, but I also want to validate data coming into my API, because as Hinek told this morning, data validation is super important when you're doing REST services. Actually, whenever you are receiving data from someone which isn't you, and even when you are the data guy sending data, you still want to validate. So Eve gives you a lot of power in controlling the data coming into your service. So we go back to our domain definition for the people endpoint, and we define a schema. So for example, the name field is a string, max length 50, and must be unique. The email field is actually a string, but also I want to validate again against a regular expression. Don't use this in production because it is horrible. And also you can define subdocuments like in here. So location is actually a subdocument with an address field and a city field, both are string, etc. You get the idea. Now data validation is super important, and there are a lot of powerful features you have available without any code to write, just by declaration. And then by default, if is read-only. So by default, these two methods are get, only accept a get request. But if you want to allow writing to your API, and you probably want, since you're doing data validation, you can say, hey, I also want to allow clients to post, so write documents over my endpoints, or update documents, replace documents, and delete, of course, documents. So all you have to do is update your array of allowed method, and the API will open your API to write or not, whatever you want. You just have to write to update this list and save your file, relaunch the server. And then there are more fine-tuning features, like, for example, if you want to set the caching header for your clients, you can configure it. As you can see, we are doing all of this in a configuration file, not by writing any code. So if you have 3 services and they're serving different data to different clients, and probably they have some settings which are going to be different between them, you just have to update the setting file for that specific service, and you're good to go. Now, what you get back from Eve as features is a number of standard features that most REST services have to provide. So for example, filtering, finding stuff on your endpoint. Here we are looking for somebody with the last name of John Doe. As you can see, the syntax here, if you are familiar with Mongo, is the same syntax as the Mongo queries. So if you come from Mongo, this is probably ideal for you, because you are looking at Mongo queries here. It's super simple, but it is also very readable because Mongo is just doing JSON. So if you know about JSON, this is JSON. Also, Eve supports Python-like syntax, like this one. This is the same query as the other one, but in Python. You can, of course, also sort your data, in this case, the sharding. And again, there is also support for Python syntax. Let me go back to our API and try a request like this one. As you can see here, I'm asking for all the people who live in San Francisco. And by the way, see that we are querying on a subfields of the main document. So location.city, and also sort them by first name in this case. Should work. Yes, we get a couple people down here. Now, this isn't very, okay. Here we have about some more space. And what about pagination? Again, this is a huge issue when you're writing REST services because pagination impacts on performance, and also you probably, it is not so easy to get it right. You get it out of the box again here, so a client can go and say, give me page 2, I only want 20 results for every page, etc. Super simple. It just comes out of the box. And the same with projections. Projections are very useful when you're doing REST services because they allow you to optimize the traffic on the wire. Because if you're asking for a document with, I don't know, 50 fields, but you only need 3 or 4 of them for the computation you need to do on the client, you can ask the server just for those fields. So your data traveling around on the wire will be reduced. So here I'm asking for all the fields but the avatar fields because, I don't know, this is a picture. I don't want to download a picture just to get a first name and last name because on the people document, on the person document, there are also the pictures, so I don't need them. Just send me everything but the picture. Or you can do the contrary. Just only return last name, for example. This is a huge optimization if you have to deal with, to care about that. And another very powerful feature, in my opinion, and people are using, actually are overusing it and then complaining about performance, is this one. So this allows you to embed a document within another document. Let's see an example. So you get, or probably I have a slide here. Yes. Then we go to the example. So here I'm hitting an endpoint and I get an ID of the author of a book, for example. It is just a unique ID. And probably I need to go to another endpoint to get the document about this author if I want to know more about the author, right? So I need to do a second request to another endpoint to get this, the details about this guy. But you can also do this at the works endpoint. I can ask for the author to be embedded, and next thing that happens is that when I hit the same endpoint, instead of an ID, I get the full author within the book document in this case. Now, of course, this is nice because the client doesn't have to perform 2 requests to the server. This is very nice, but keep in mind that in the case of Mongo, for example, you don't have joins. So what the server is actually doing is performing 2 queries on the database itself for you. So one single request instead of 2, which is very nice, but there is an impact on performance anyway because the server is going to perform 2 requests on the database. But many times this is very nice, especially if you are providing services to third-party clients and on clients on which you have control. And also there is support for JSON, but also XML if you need it. Let's see a couple of queries again. So here I'm asking for the owner to be embedded. We already saw that in the slide. And let's see what I've done here. Yes, as you can see here, this is the works endpoint, so the books basically. And the owner I'm seeing here is a full document. Now, if I don't provide this, the real, the basic feature, let's call it this way, the real document on the database is more like this, where the owner is just, it is just an ID, right? And also requesting XML to a Eve-powered server it is just a matter of passing the right header, as you can see, accept XML, and when you send this request over, what you get back is XML instead of JSON. If I perform the same request without that header, I get JSON instead. Of course, most of these features we are seeing, they are all active now, but you can fine-tune what feature you want on your service or you don't want. If you don't want to support XML, you just switch it off. The same with embedding, for example. You can pick which fields are embeddable, which are not, etc. So you have control over everything. Okay, we already saw the XML thing. Engine as application state, we already mentioned it. Here we see a more interesting example. We are hitting some document and we get all the links to the parent endpoint, to the next page, or the last page in my query, etc. So as you can see, the client can easily navigate our service just by, if you write a parser of this stuff, you can expose an API, for example, a button which says next page on your client, and the actual label of that button, you can pick it up from the API here, title, next page, you put that in your button, and then when the user clicks, you make the button send a request to this link, and you see that it will navigate your service, and if anything changes on the service, you don't have to touch your client because it is navigating based on the API instructions. I find it to be a very interesting concept that it is not very used, but should be. Document versioning. This is a feature which has been contributed by the guys working at a space agency I cannot mention, but they just sent a car to Mars, and this is very interesting because they implemented basically is diffs and document versioning. So you can go and ask for this person, but as it was 3 versions ago or 5 versions ago, or you can ask a diff between 2 documents. For example, this is very interesting, very powerful, and not everybody uses it, again, but you can switch it off. File storage, you can send files to if-powered services, so I don't know, images, scans, or whatever you need to store. Again, super simple. When you define a field in the endpoint, in the settings file, you just say, look, this field is a media file. A client at that point can perform a request and post a picture, for example, and when they download the document, what they get by default back is a base64 encoding of the pictures. And this file here is going to be stored, in the case of Mongo, for those of you using Mongo, it's going to be stored on GridFS, so optimized for performance, querying, and stuff like that. And you can also opt for extended media info, which isn't very interesting, but you can also configure Eve to store the file on GridFS, and then when the clients have to download it, instead of serving the file with the main body of the document as a base64 string, you can actually tell Eve to serve it at a specific dedicated endpoint. So the client can go and download the picture directly at the dash media endpoint. And then there is rate limiting. Hinek and Tarek mentioned this morning. It is super important when you're doing any REST service. You want to make sure that no clients are going to dose your service because they are sending multiple requests too many times per second to your API, maybe just because of a bug in the client, for example. It happens way more often than you might think, that there is something going wrong on the client side, or maybe somebody is doing a DOS attack actually and hitting your API continuously. Well, you can limit it. Here, for example, we are setting a rate limit of 1 request per minute, which is very low, but just an example. So 1 request every 60 seconds. If you do this, when a client performs a request, the response has some special headers, and for example, here is you are left with 0 requests. So this request was okay, I'm providing you data, but for the next 60 seconds you can't send further requests at the same endpoint, and the next reset is happening here. This is an epoch. So you can, of course, fine-tune this. The whole point is avoid a client to perform too many requests per second on the endpoint. This is super important. You should always, even if you don't use EVE, you are building services, implement rate limiting it right from the start. So if you perform a second request within the 1 minute window in this example, you are going to get a 429 error, too many requests. And yes, if you wait the minute, you perform another request, 200, okay, you can get the data again. Conditional requests are about not sending data to the client which if it is not needed. So basically, there are two aspects in conditional requests. One is not sending data to the client if it is cached already on the client, and the second is performance again. So, for example, the client can say, send me data only if it has changed since a certain date. This is a classic you find in all kinds of RESTful services. This is more interesting. This is similar, to if modified SID, if modified if. Every document served by if has an e tag, which is basically an hash on the document itself. So when you perform a second request for a person, for example, on our people endpoint, you can say, send me the person only if the e tag has changed, if the hash has changed. If nothing has changed, don't send me anything, because I already have my local copy, which is still the right one, the most updated one, right? Okay, thank you. Let's see this in action. So here I'm hitting, here you see I'm hitting a specific person endpoint. So people is where I get a list of people, but if I go to the single ID of one person, of course I get the person. So if I try a simple get, I get the whole person. But if I go and pick this other request, which is identical, but has this if none match, and this is the e tag of the person. Let me go back to the previous request. If we look here, we have an e tag field here. So all I have to do on my second request is get at the same endpoint if none match the e tag. So basically, in this case, I'm going to get nothing back. But if you look at the response status, it is not at 200, 304, not modified, which means, okay, I got your request, I went, I checked, you already have the document there, so I'm not sending you any data. So this is, again, nice and important if you're doing microservices. What else? Okay, create. Well, this is, you have to actually enable writing on the endpoint. If you do, you can then write. As you can see, the request here is a post, so I'm writing. I'm serving content type, as you can see, JSON here. And the body of the request is going to be my name and last name. Let's see if it works. Yes, so we got a created response from the server, and the JSON has all the metadata needed to access my person, of course. And by the way, EVE also supports bulk inserts, which means you can, with a single request, send multiple documents, and they will all be stored to the server in one request and response cycle. You can switch it off if you want to, but it is, again, very nice if you are to write, I don't know, 10 invoices. Instead of doing 10 post requests, you can just do one request and send an array of invoices over to the server, which I think is the point of the next slide. Yes, here we have an example. I'm just sending an array of documents, etc. When you get the response from a bulk insert, as you can see, you get the link to every single document which has been created on the server. All right, yes, you can also configure the server to provide the whole document back. The coherence mode on basically means don't only send me back the metadata, I actually want the whole document back with the metadata, which is very common when you are writing clients with objects. For example, we use REST services from C# actually, and we have models, data classes basically. We an user inserts a client, a person, and then we save it on the server, and then we want to give back the client the whole object updated. I can do that very easily. The whole JSON will contain the new updated documents. And also, the headers are very important when you perform a request and you want to make sure that the data is not overwritten with obsolete versions of the documents on your server. For example, I have two clients. Both are trying to update an invoice. One updates the invoice. The other one tries to update the invoice, but the copy on his local cache is now older than the one on the server. How do I prevent that client from overwriting the newest one, which is already on the server? You do that with the headers. And so basically the idea is the same we saw before with, I don't know if actually I have, yes, I could go here. No, I'm not sure I have a demo, but it's super simple actually. So for example, here I'm patching, which means I'm editing a document. I want to update a document, but I'm not providing any if-match header. If I do this, the API will reject the request because there is no if-match header, precondition required. If I provide an old e-tag, because I have an old copy of the document, the request is equally rejected with a different response. Precondition failed. You gave me an e-tag, but look, the document you have locally is not updated. I have a newest copy on my server, so I'm not going to accept your update request, because otherwise I would overwrite my newest copy with your oldest version of the document. Okay? If I provide the right e-tag, which matches the one on the server, then okay, I'm taking your update and accepting it. This is another huge problem with most APIs at Wild. You can overwrite with all documents. Here you have a mechanism by which you avoid that. Of course, you need to have clients who know how to deal with how to handle this kind of request. But most of the time you are writing the clients, you have responsibility for the clients as well, so you can code that, or you can document these features so people working on clients can handle that. Here we see a few examples of data validation. By the way, data validation is powered by Cerberus, which is a different package, and it is another project of mine. You can go actually and use Cerberus for data validation in your own project without EVA and all the stuff which has to deal with REST services. It's a very nice project, I believe, right? Other assorted things, for example, there is a support for GeoJSON. So if you are Mongo, again, you know that Mongo allows you to write GeoJSON information on the documents. And then if you are writing line strings, polygons, whatever, you can query for example, give me all the places which are close to my hometown. And the API will provide you all the people living close to you, etc. Just out of the box without having to code anything. And by the way, this is another feature which has been totally contributed by the community. Very nice. This is the power of open source, right? Authentication and authorization. There is support for a number of authentication schemes: basic authentication, HMAC, MAC authentication, token authentication. I'm not going into the details now. I just want to show you in a few seconds how you code that, because it is very simple. You can launch your server on whatever Python you're using, but you should really be using Python 3 by now. I don't know if you got the memo, but in 2 years, less than 2 years, Python 2 it won't be supported anymore. So if you are still on Python 2, consider upgrading. Can be done. I had to upgrade the whole code of Eve to Python 3. I thought it was going to be terrible. In fact, it took me just one afternoon or something like that. So if I did that, you can do that as well. And rest assured, it is going to be all to your advantage. And many other features, support for calls, for cache control, uplog, soft deletes are also very nice. So when a client deletes a document, you actually don't delete it, you flag it as deleted, so you can retrieve and undelete it later on. Logging, custom ID fields, etc., etc., etc. For you guys working on Mongo, there is also support for the Mongo aggregation framework, which means that you can have endpoints serving aggregation data back to the client. So, very powerful. It is open source. Do whatever you want with it. You don't owe me any money. And until now, we haven't, as you probably noticed, we didn't write any code. We just have been playing with a settings file. All these features comes without anything to code at all. I want to show you some code actually. First of all, you can build custom data layers. Let's say that you don't want to use Mongo. You want to use, I don't know, Elasticsearch or Postgres. You can do that. There is a mechanism for that. You have to override, to inherit from the basic data layer and then write a few methods, and you can basically connect it to whatever you want. This is the actual code for the Elasticsearch data layer, for example. And if you use this, you can connect to an Elastic server. There is also here it is. An official sort of community effort for supporting SQL databases, etc. Let's see authentication. You can have all kind of mixed matches of authentication schemes. So for example, you might have some endpoints which are public. You want everybody to download from some endpoint, but some other endpoint have to be protected. Maybe you want everybody to read, but just a few clients to write, all the kind of mix and match. You have a lot of features, so you can also enable role-based access control, user-restricted resource access, etc. But what I really wanted to show you is this. If you want to allow for basic authentication, all you have to do is import, in this case, the basic auth class, which implements basic authentication, of course, and then you inherit from it, and you only override one method, here checkout. Here, for example, the method receives a username, password, and a number of other arguments, and then you implemented your own logic for authentication. So it doesn't force you to do authentication in one way or another. For example, in my own production case, here, what we are doing is actually hitting a different microservices, which is responding to us, yes, this guy can access the API or not. But you might have just a simple if as this one, or whatever you need to do. You implemented your own logic for authentication. And then when you launch you instantiate your Eve class, you just say, hey, look, you need to use this authentication class. And that's it. Let me go back to our server, stop the server, and relaunch. All right, this is the same script with the class which performs authentication. Now, if I go and try to get the people endpoint with a GET request, I should get a 401 because I'm not authenticated. If I go and perform the same request, but with my authentication header, should hopefully work. Yes. Now, if you go back and look at the code, I don't know what you can actually. Let me try. Yeah, this is the code. Can you read it? Kind of. As you can see, I'm just importing Eve, the basic auth class, defining my logic, authentication logic, and that's it. So 1, 2, 3, 4, maybe 4 lines of code, not counting the usual test at the imports, and that's authentication for you. Of course, you probably are going to do something more complicated here, but that's up to you, okay? All right, back to the slides. I'm almost done. Okay, custom validation, again, you can do whatever. I don't have time. I actually have a whole talk about data validation, but we're not going to see it right now. You have, and again, Hinek mentioned the importance of normalization. Not only data validation, you also want to normalize your data. Make sure that the data coming into your databases is standardized. You can also do normalization, for example, force a certain string field to conform to a certain format. You can transform the data coming in. And last, I want to show you event hooks. Because this is Flask, we can do stuff like this. Actually, not just because it is Flask, but because we're using callbacks here. So here I'm defining a function. It is going to receive the endpoint and the documents that somebody is trying to write on my server. And I am updating the document, every single document, with whatever value I want. I want to add a field to the document as the document comes in. I could do that with a very simple function. And then when I launch my app, I just say, look, on insert, on every insert, you have to execute this function here. And it will just do that for you. Let's try this. I don't remember what's the name. Hook. Yes, hooks. Now let's go and back our request. Should be, yes. Now I'm transforming my data. When this is a different code than the one I just showed you, because this is doing the transformation while reading. So every time it reads from the server, it updates the document with an unexisting field on the database, but it is still returning it to the client. Again, this is very common. You have some work to do in the business logic layer of your app. You can do that very easily in writing, but also when reading. And because this is Flask, we can also do whatever we do with Flask. So for example here, this is an Eve app, but also defining a custom endpoint and writing some Python code at that endpoint, like this one. This is classic Flask code. If you're using Flask, you know, just replace Eve with Flask, and this is Flask. And of course, this allows you to customize your endpoints in so many ways. I really have trouble giving you an example, but I actually have this guy here, and if I go and hit the hello endpoint, I get a hello world response, as you can see here. So this is not Eve code, this is my custom code. I just built a custom endpoint which expands on the data endpoints. People here is still working, as you can see. So you can mix and match your custom endpoints with the Eve endpoints and do whatever you want. I think we're done. Yes, you can, of course, add authentication to your custom endpoint as well. You can do custom file storage. Again, you can also expand the file storage if you want to save your images on S3 or wherever you want, file system. You can do that. There are a number of extensions. This Eve Swagger is very nice. It allows you to have automatic documentation for your endpoint by using Swagger, Open API, etc. if you know about it. So you have your endpoint, your API, and you also have a /docs endpoint where people can go and read everything about how to consume your API. This is a community extension. And there are data extensions, as I told you already. There are clients. For example, this is a C# client for Eve, which I wrote myself because I needed it. There are JWT authentication systems, for example. This is written by the CTO of Netflix. Very nice guy, by the way. Flask Sentinel, etc., etc., etc. The whole point is there are many other community features around the main project you might want to look at. And of course, we are looking for contributors. There is a lot of stuff to be done on the project, maybe also simple stuff like updating documentations, fixing links, stuff like that. If you want to get involved in open source, the project Eve and the project Cerberus are looking for contributors, and so you are welcome to go and submit pull requests, and I'm there waiting for you, basically. So come and join me. And this is my Twitter handle. If you want to get a hold of me, get in touch, my website, my email, and most importantly, this is the site of the project, if you want, and look it up. And also, I'm right now writing, I don't know if you know about the Talk Python podcast. I'm right now recording a course for Michael Kennedy, which is the host of Talk Python. So in a few weeks, there will be a course a class you can actually take on Eve. It is not really needed because we are all developers, and the documentation on the website hopefully is done well enough. You can go and write your service right away without my course, but just to let you know that there will be available soon. Thank you. If you have any question, I don't know if we have time.
Yeah, we have enough time. Thank you a lot for Nicola. It was a great talk. And it's time for questions. Yes, go ahead.
First of all, thank you for the application and Kerberos especially. I'm the person who used Kerberos since it had just appeared on GitHub, probably.
Really?
Yeah.
Great. You made my day. Thank you.
So I know this for quite a long time, and my question is, can I query tree-like data from Python Eve using the Mongo-like query language? Let's say I'd like to check all fields on the third layer of tree against against some property, for example. How can I do this?
You mean querying the database for some fields which are at the third level of the tree of the documents?
Yes, I store tree-like data in database, and I have a resource for this, and I'd like to query this resource for example, third layer, some property for that.
Well, that's probably a Mongo problem. If you can do the Mongo query, you can do the same in Eve itself, because basically what I'm doing here is using abstract syntax trees and mapping to the Mongo query directly. So you should look it up on Mongo and then try in Eve. Most of the time it will work without any issue. If it doesn't, just open a ticket and we will look at it, but should be just work because it should just work fine. I don't see any problem with that. Eventually, you could, if the tree is too complex and you have trouble, what you might want to do is define a new endpoint. By the way, one thing I didn't mention is that you can have multiple endpoints in your API all eating the same data source with different results or configurations. And one configuration might be an aggregation framework query. So basically you have an endpoint where clients go when they need data formed in a certain special way, and you have aggregation from Mongo pulling it up for you. So that's very powerful because you have a specific endpoint, you only hit it when you really need to, and you can do stuff that a normal query Mongo wouldn't be able to do. So look it up.
Okay, thank you. We have time for one question. Yeah.
So, thank you. It was quite interesting. But if is such a proxy in front of MongoDB, it was built for MongoDB, I think, and it was built on the basis of Flask. But it is input-output intensive. What about building it on the basis of IO HTTP?
So the question is, what if I want to use Eve not for I/O, just for sending data, but for some more complex business logic and stuff like that?
No. what is your thoughts about building it with async.io?
Ah, all right. Well, this is a Flask issue, actually. Flask is is not an async framework, and so you have a hard time doing async with Flask, and you can probably do that, but I don't have any user reporting back to me about using it in those environments, so I don't have any information. My idea about REST in general is that it is not an asynchronous process. I mean, when your client is sending a request to a server, it's going to wait for the response. It's not going to do anything. I mean, the client can do other stuff in the meanwhile, can be async itself, but the process with the server is a synchronous request. So in that case, it doesn't really have a lot of sense to work async with a REST server. I'm talking the client versus server, of course, communication. But with Flask, doing async is going to be kind of troublesome in general. I mean, it's not an Eve problem, it's a problem of Flask itself. There are some other very interesting frameworks coming up in the last years, which are more async oriented. You should probably look them up if you are very concerned with async, restless framework and stuff like that.
Thank you.
You're welcome.
Thank you. And thank you, Nicola, for your talk.
Thank you, everybody.